Yesterday we talked about authentication protocols, and then we talked about single factor, two-factor, and multi-factor authentication. We talked about the authentication protocols that we typically use with username and password and kind of left it there. Tonight, this one is strong authentication. We're going to get into some of the other things that can be added to make authentication necessary. And keep in mind, we're doing all this authentication just so that users prove who they are to get on the system. We haven't protected the data with encryption or anything like that yet. We're just at the point that we're getting people onto the network, onto the system. So the objectives are: describe the features of token-based and biometric authentication, and those are going to be the other factors we're going to use. Describe the operation of and identify vulnerabilities in different authentication products and protocols: EAP, Extensible Authentication Protocol; PEEP, Protected Extensible Authentication Protocol; and LEAP, Lightweight Extensible Authentication Protocol. And then we'll talk a little bit about Radius and TACACS. And get that. Okay, TOTP and HOTP. Understand the use of federated identification and authentication services. With Microsoft, federated was something that kind of became new in Server 2008. What it basically is letting another corporation into your resources. So token-based authentications use tokens, smart cards, digital certificates, those types of things. We tend to use, and it says user chosen passwords are weak, and that's typically going to be the case. We're going to use something that's convenient and probably as convenient as possible. And then we get into the complexities, what we have to have, and then you have to have an uppercase letter and a number and a special character, and then some of them won't take special characters. But what these other devices do are help us to make authentication more secure. It also can kind of complicate the situation and maybe increase the support costs if it doesn't work. And we're going to have to learn how to manage those things anyway. A smart card, an indication of one here is a credit card size card, and I guess you could call a credit card a smart card, or at least a semi-smart card. They're getting smarter with the chips. It has an integrated chip and the data on it. They can be contact-based, meaning that you actually slide them in and it reads the strip or something like that. Or they can be contactless, which has a little transmitter in the card. One of the places I was at, we used the contactless ones. You wave the card in front of the locks on the doors, and they would let you. It would open the lock with those. So those are one way to do it, and each of these is going to have a digital certificate on it, a way to identify that individual. And we also have smart cards. Smart cards, say, and these are digital certificates. Smart cards are the things that I've been talking about. Digital certificates, we looked at those a little bit. They're the things that are actually going to identify us. They're going to be unique, and they're going to go into each of these devices. Next, we talk about USB tokens. Similar approach here. They plug into a USB port, obviously. They have the digital certificate embedded in them, so we can use them. Key fobs, all of these devices, different physical properties, but they're all going to do the same thing. They're all going to have a smart card, or smart cards. They're going to have a digital certificate on them to identify us. And when you use these things, you're going to have to put a PIN in also. So we're going to have usually two-factor, and you have the device. So the two-factor is going to be something you have and something you know. In this case, the something you have, the smart card, USB token, key fob. The something you know would be the PIN that goes along with it. Downfall of these is if you lose that, they can be lost. There's going to be an expense involved in them, but they are going to make it more secure. The next thing is one-time passwords, and these things generate, and they use obviously software on the server that you're authenticating to, but they generate a password that's good for X amount of time, usually a minute or 2 minutes, not very long, and then you use that password to sign on. They have to be synchronized. They usually are going to have a time component, and the time component, if you remember, is the thing that's going to prevent us from doing playbacks on these things. The RSA Secure ID is its time plus a secret value, and then we're going to have a code plus a PIN. All of these things are generally going to be two-factor authentication. Open authentication, the OATH, open authentication, is a framework. HMAC, which is a hashed, it's based on a one-time password algorithm, so that's where the HOTP comes in, the HMAC one-time password, and then the time-based password. And what these things have is, over here is, Frank wants to get authenticated, so user Frank goes he's in the user table. Then we have Frank's counter, maybe from one of these things, well, not from this thing. They actually have a counter on the device, how many times you've used it, and then Frank's secret. These things are put together in a cryptographic hash and sent to the server. If they equal, and the server is going to create its own hash based on the same information, Frank's counter and Frank's secret. If they're equal, then you get in. If not, then you obviously don't get in. There are some vulnerabilities in these things, although they're going to work much better than just the username and password. Main concern with something you have is that you can lose them or they can get stolen, and the device can be counterfeited. If you want to make it stronger and more expensive, you can link this also to some type of biometric authentication to go along with it. So one-time password, the open authentication framework, we're going to have the same shared secret, and that is one of what we have to do, and that becomes, as we know, how do we keep them? It's the same shared secret from one to the other. Some of these things, it says the fob or smart card, a phone app can actually get the shared secret through a QR reader so that it gets changed regularly. Otherwise, the shared secret is going to be part of the something that we know with these things. So that can be one of the issues with these things. The vulnerabilities, loss, or theft. An example of this may be the Google Authenticator. And also maybe single sign-on. Google's kind of getting there with a lot of different things, because I see more and more places where you can authenticate with your Google Plus password. So Google Authenticator, and what we're going to do with these things, with the two factors on them, typically when you use it, is they're going to text you a code that you have to put in after you do your login. Biometric authentication. The biometrics costs and error rates can be an issue, and throughput if it is a particularly busy, and one of the things they talk about, if it's at an airport or a train station where you have a lot of users going through, biometrics may become an issue. You have to enroll users into the biometric system. So we have a sensor, and then we have feature extraction, where it extracts the major components that it's going to use for identification. Template storage. The template is going to be all of the features that are stored to do the comparison with, and that has to be secure storage, obviously. The error rates can be high in biometrics. I think they're getting much better than that. We think about them as fingerprints, but the types, we have fingerprint recognition, iris and retina scan, facial recognition, and then behavioral signature, voice typing. All of those types of things can be part of, or are part of, the biometric authentication processes. Biometric technologies, some users may find them intrusive or threatening to their privacy. May not be usable, some of the issues obviously, may not be usable by users with disabilities. The setup maintenance costs can be high. The error rate can also be high. Susceptible errors, false negatives, false positives. So that's both sides of the coin. The crossover error rate, where the biometric is judged, the crossover is the point at which the FRR, the false rejection rate, and the FAR, the false acceptance rate, meet. The lower the crossover error rate, the more significant and reliable the technology. And then throughput speed, airports, rail stations, someplace, if you're using biometrics for identification, places that have a lot of users going through, may be an issue. The technologies, the fingerprint recognition's easy to use, relatively inexpensive, can have issues with fake finger, somebody dedicated. The more sophisticated ones check temperature and pulse in the finger, but the ones that we would get, the ones you could get for $49 or $25 or whatever at Walmart, is just going to look at the image of it. And the thing you got, and usually these are going to have more than one fingerprint, you would hope, because what if you burn your finger or something like that? You will now not be able to get into the system. So yeah, again, the extraction of what we're going to use, and you may need to have more than one input into the template that's used. Eye recognition, retinal identifies blood vessels. It's expensive and can be not false negatives if hay fever season, for instance. You may have a problem if you have diseases. Eye diseases can cause an issue with false negatives on these things. The iris scan does the surface of the eye, and it's supposed to be less intrusive. I've never worked in any place that had any of those types of scans. Facial recognition gets a kind of a bad rap. The facial recognition uses multiple points of the face, obviously, for the recognition. May be uncomfortable to the user. And then we have the behavioral, the voice, the signature, and the typing. The voice recognition signature is more than just the shape. It's the way you sign your name, the pressures that you use, how fast you use the stroke, and those types of things. And then typing, with me, it would have the error rate, and it would be really big. So typing can be one of those things. So behavioral technologies are also available through these things. The common access card, and I think this is what you guys that were recently in the military or still in the military have. Is that a true statement?
Yeah, they still have CAT cards.
Yeah. It is HSPD, which is a presidential Homeland Security Presidential Directive 12 mandates the use of secure authentication and identification for the U.S. federal government. And I think these things, they have a chip on them, which has a certificate on them, true, and then they have your picture on it. And
yeah, it's just a thing like your smart card, like you see on the new credit cards. It's the exact same thing.
yeah, are these the ones that have your some of your medical history on it too?
As your medical history, like a lot of it will actually have your transfer, information, stuff like that.
Yeah.
Your blood type, certain factors about you.
So these things, if you can compromise them, you can get a lot of information off of them. Common access cards used by DoD, personnel identification, verification card used by other federal agencies. That's a mouthful. There are also first responder access credential and e-passport. So what we're saying is that we're going more and more and more to the digital age for digital authentication when you do that. And I'm going to go back to you, Kevin. Can you use this thing? I think it can. The ones that guys that had were reservists talked about those, that you could use them from home to authenticate to certain places.
Yeah, what they do is they give you actually a USB drive CAT card reader, and before you actually do that, you have to actually go to actual PERS, and they actually set up to make sure you're authorized to use it at home.
Okay. So it extends out to, and you have a PIN also, right? So you have multi-factor?
Well, no, actually, so once you've actually set up your CAT card, there is a PIN, so it's got a keypad that you actually do.
Yeah.
And it looks just like the old school, kind of like you think of it like a zip drive, except all it does is it fits your CAT card or a credit card into it.
Okay. Kind of like the new ones where you have to insert your credit card instead of swipe your credit card. But
correct. That's the exact same thing what they do with actually the CAT card readers.
Yeah. Issue here kind of still becomes security. What do you do with the PIN? That's why I wanted to go through all that. How closely do you protect the PIN? Can somebody steal the card? If you can steal the card and get the PIN, then you can use this thing out of the presence of individuals that could actually see you. I think one of the things, mostly what we think about authentication is we're going to go into the office or into a computer room or something like that to do those things. So we have multi-factor authentication and identification. A smart card's got a token, it's got a photo ID, and then a PIN on these things. So it has a lot of different factors in there to try to positively identify the individuals. I save the attendance. Extensible authentication protocol is something that's supported by the newer operating systems. What this is going to allow us to do is have an encrypted sort of authentication process. So what we have, and there's a couple of new terms here. One is supplicant, and then we have authenticator and authentication server. We're used to talking about client server and those types of things. In this case, the device that we normally think of as the client is going to be called the supplicant. The authenticator is going to be the device that we're trying to get access to. And then the authentication server is going to be the device that holds the usernames and passwords to check what's going on with these things. We have a couple of them here, EAP, TLS, and when you see TLS in most cases, think certificate. It has certificate and smart card support. The server and client have certificates. So the server and client authenticate with each other. PEEP is Protected Extensible Authentication Protocol, and it uses a password authentication through the transport layer security protected tunnel. Only the server has a certificate in this case. So, and the server here is going to be the authenticator. The communication goes between these guys here. This authenticator can be a lot of different devices. It can be a switch. You can use this process for wired or wireless. This could be a wireless access point. I'll put up a video of how you configure this on a wireless access point, how it sets up. Could be a switch, could be a number of devices that we want to use. LEAP is a Cisco version. It was a very early version, lightweight, and it's really not used very much anymore because it wasn't all that secure. And then EAP MD5, the message digest we're going to use with the password. What these things are going to do is set up, let me go to the next slide here, yeah. What we're going to do here is set up a secure connection. So what we have here is an 802.11, and it went too far, didn't I? 802.11 association request associate 802.11 associate with the wireless access point. So we get the association. The EAP start, we send a packet we want to log on to the authenticator, the wireless access point in this case, even though it doesn't show here. It's just the generic authenticator. It sends back a request identify, request our identity. We respond with the identity. It then sends that identity request to the, in this case, a Radius server, which is the authenticator we can use, or the authentication server that we're using here, Radius, or we could, and it may actually go out and ask an Active Directory server for that. And then we get the Radius access challenge, the EAP request, EAP response, and on back and forth the response. And then EAP success, the key, here they say WEP. We really wouldn't want to use WEP, but we can use, what this one's going to use is Enterprise WPA or WPA2, and it won't use WEP for the key. So these messages, nothing happens. There's no communication except for the EAP traffic gets passed back and forth. If we had a switch here, we could have a wired switch where we actually made users authenticate to the switch. The ports would be turned off until we actually authenticated to the device. All the EAP messages would go through the switch, but nothing else. And you wouldn't get an IP address until you actually, IP address on the machine until you actually authenticated to the server. Radius and TACACS are large scale, I guess, maybe we want to say, authentication devices. It shows a remote access server, AAA server, when we do these things. Wireless client devices go in here, and this is going to be the AAA server. The AAA server is going to either be a Radius or a TACACS. What this is showing is we have multiple devices that are using the same Radius server in order to authenticate users. A Radius server can authenticate numerous devices. If we had the 802 or the EIP, the PEEP for the wireless access point, it would use the Radius server. The remote access server uses the Radius server. We can have a lot of different devices to do that, so we can have large-scale authentication by using these devices. Radius is remote access dial-in user service. All of the VPN stuff those sorts of things are in fact going to be dial-up services, dial-in services. TACACS TACACS was originally distributed by Cisco. They made it a standard, then they stopped supporting it, then they came out with TACACS Plus, and TACACS Plus is a proprietary Microsoft. Proprietary Cisco. So Radius, remote authentication, dial-in user service, Radius. The remote user connects to the Radius client. When we talked about earlier, the Radius client is going to be the authenticator. And what we really have here is supplicant client and authentication server. So it connects to the client, such as an access point, switch, or remote access server. The Radius client prompts the user for their authentication details, such as a username and password or a digital certificate. You can set these things up to use either username, password, or digital certificates. The client, remember the client's the thing we're trying to get access to, uses the client logon to create an access request packet, and the access request packet sent to the AAA server. In our case, the AAA server is going to be the Radius server using UDP on port 1812. So if you're going across a firewall, that needs to be open. AAA server decrypts the password. If it can't be decrypted, the server doesn't respond, and then it checks the authentication information. What I have found in this whole process is that it's going to be most of the failures that I've had setting this up have been with the certificate that the client provides, that both of them have to trust that individual, has to trust that one. So if the authentication is valid, it responds to the client with an access accept packet, otherwise they get a reject. And if you're not getting logged on, this is a place where Wireshark comes in handy, so you can see what's working and what's not working. So the client checks the authenticator in a response packet. If it's valid, they accept and request. Then you get the start packet. It's on port 1813, and then it opens a session. The server processes the accounting request and replies with the accounting response. So basically what it's saying, after we send all this stuff back and forth, we're going to get authenticated to the resource that we want. TACACS, these ports, it says ports here, I'll go back to this. This one uses UDP. I can't do that. So Radius uses UDP. When we get to TACACS, it's going to use TCP. So it says reliability is improved by using TCP, and it uses port 49. But Terminal Access Controller Access Control System TACACS Plus, and TACACS Plus is the one that Cisco uses now. It's similar to Radius, but it's designed to be more flexible and reliable. It uses TCP. Developed by Cisco, it also supports many other third parties and open source Radius server implementations. Microsoft servers have a Radius server built into them. There's also open source software that are Radius servers that you can get. All the data in TACACS is encrypted except the header identifying the packet as TACACS plus data, because if it were encrypted, it wouldn't be able to identify it as a TACACS data, rather than just the authentication data. It was developed in the 80s, upgraded by Cisco as the proprietary protocol XTACACS in the 90s. And Cisco ended support for these in 2005. So it's still around. Radius, I think, is the standard that most people are using today to do this type of authentication. Federation and trust. Federation means that the networks under a separate administrative control share users. If you have two companies, what that means is company A can get on company B's network. As in here, the federated services, we have a company over here, resource partner organization, account partner organization. So one can have access to the resources on the other network. That simplifies having to set up, if you're going to share this information, a whole set of different users and passwords. So you accept the logins from the other network. They got to establish some sort of a trust relationship, and in the trust relationships we have several different ways to do it. First, we have transitive and non-transitive trust. A transitive trust is if A trusts B and B trusts C, then A trusts C, so there's a flow through of the trust there. A non-transitive trust is if A trusts B and B trusts C, A does not trust C, so you have to have direct trust in these things. We have one-way trust. The child trusts the parent, but the parent doesn't trust the child, so company A can get on company B's resources, but not the other way around. And that may be a case if you have sales partners or something like that, I guess. Two-way that is both of them trust each other. The child trusts the parent and the parent trusts the child. And I talked about transitive and non-transitive. So when you get in, we'll talk about Active Directory, but you can have forest trusts or domain trusts in those things. The markup language, Federation provides a sort of a single sign-on on the web when we allow them to use the resources of one or the other. The client or principal initiates a sign-in to the service provider's site. The service provider directs a sign-in to account hosted by the identity and authentication provider, Google, Facebook, Twitter, those sorts of things. The identity provider validates the credentials, provides the authorization token, and the principal is signed into the service provider's site with a token. And again, I think that I may just be me, but it seems like I see more and more and more of that on the internet. And then the protocols to identify the security associate markup language. I tried going too fast. Open authentication, open ID, the different mechanisms, but they really are doing a similar purpose. Mechanisms, the SAML, the service providers and the identifier providers don't communicate directly in these cases because we're going to get the token. Use different underlying protocols, XML, HTTP, SOAP, JSON, and XRDS, and I don't know that you'll need to know those things. So what this one was about is the features of token-based and biometric authentication. The features are that we have these cards and we have certificates, basically. Biometrics, something we are. Of the factors, something we know, something we have, and something we are. These are the devices that are available to take advantage of those. Operation and vulnerabilities of EAP, PEEP, LEAP, Radius, TACACS, TOTP, and HOTP, the use of federated identification and authentication servers. Oops. So we're going to do the questions now. I know everybody's looking forward to that. Let me get this going here. True or false? An account requiring a password, PIN, and one-time password is an example of a three-factor authentication. This is a 50-50-90 question. I don't think Dean's here tonight, so somebody else is going to have to take over for him. What did you say? What say you?
I said true.
True. Anybody else? What do you think, Kevin? He's been having trouble getting off and on. So what we have here is a password, a PIN, and a one-time password. Are there components from each of the three? A one-time password is going to be something we have, right?
Yes.
A PIN is going to be something we know, true?
True.
A password is going to be what? I'm not trying to embarrass anybody. Password is going to be something we know also. So when they say three factors, it's not three things. It's from each of the elements, something you have, something you are, something you know. So this one would be actually a two-factor password. What type of login security is provided by one-time passwords? Kind of like when you get a password reset. Do they give you forever to do it? I know you guys have had to reset a password at least once, haven't you?
Many times.
Where they send you the email, what do they tell you got to do?
You gotta click on the little link or whatever.
Yeah, how long is it good for? Forever?
No, it usually says like what? It depends, like 24 hours or something.
Some of them are that way, but one-time passwords are a lot less than that, and that's what its security gives you. That's valid only for a very short period of time. Usually somewhere around a minute. So you got to use it right now, or it goes away. And then with the time component, you can't do a replay with it. Apart from cost, what would you consider to be major considerations for evaluating biometric recognition technology? What would be the problems with it? Why wouldn't you use it?
False positives.
False positives, so it's going to error rate. And let me get back to the slide. And here we go, throughput speed. If you got a lot of users that need to go through it, use it, it may not be as fast as you need. Which type of eye recognition is easier to perform, retinal or iris?
Iris.
Iris, yep. True or false? The holder of a common access card can authenticate to a computer system using biometric information stored on the card.
True.
True.
What's on the card? The slide here. What's on the card? We have token. What's the token going to be?
That little chip thing.
So what would we have to have if we have biometric information on this thing? Does it have any place for biometrics?
No.
So no, it doesn't. It uses the something you have and something you know. Something you have being the card with the certificate on it, something you know, the PIN. Which remote authentication protocol supports smart cards?
True or false
False.
on the last question?
False.
False.
Doesn't have any. It has a certificate. Doesn't have any biometrics. Which remote authentication protocol supports smart cards?
Let's see.
You guys looking at the slide?
Oh, is that the EAP?
Yeah, PTLS.
Yes.
Certificates. What is a radius client? Which is the client? So which is the radius client? We have the supplicant, client, and authenticating server, right?
Mm-hmm.
So the client is the thing that we're trying to connect to, the resource that we're trying to use. Is a device or server that accepts user connections. Use radius architecture. The client does not need to be able to perform authentication itself. It passes the logon request to the AAA server. The client does. Which of TACACS, TACACS Plus, and X-TACACS are most likely to be deployed on networks? I'll do that one. It's TACACS Plus because Cisco dropped support for the other two in 2005. TACACS Plus is still in use. And you can get Cisco authentication servers to use with it. Your company has won a contract to work with the Department of Defense. What type of site access credentials will you need to provide? What were the things that you needed for DoD? Are you looking at the slide? So if you're doing DoD, what do you got to have?
Common access card.
Common access card.
The personal ID
Yeah.
verification.
Yeah, one of those, but the contractors would have to have a common access card. You are working with a cloud services company to use their identity management services to allow users to authenticate to your network. The company will not establish a transitive trust between their network system and yours to allow you to access and update user profiles. Why would they refuse to do this, and what impact will it have on your application? So where were those trusts? So why wouldn't they want to do a transitive trust? What does a transitive trust do?
Is that one that extend to other trusted domains?
Yeah, if A trust that A trust B and B trust C, the problem here would be they don't want you to have access, so they're not going to do that. And what they say is they would have to obtain user consent for your network to access their profile, and that's maybe difficult for them to do. You'll have to create and store the profiles on your own network to allow users to authenticate on your network. So what they would probably want is a one-way, a non-transitive one-way trust, so that their users do it, and then you wouldn't have access to the profiles. Questions? Okay, let's take a look here for a few minutes at authorization and account management. It's going to focus mostly on Microsoft and Active Directory when we go through these things. The objectives: understand privilege management policies and the assignment of rights to user groups and roles. Use directory services and system policies to configure user rights and roles. Configure password protection and account restriction policies, and perform user access rights and permission reviews. Remember, in the AAA, we have authentication, which we prove who we are, authorization, which is where we get access to resources, and then accounting, the logs, where the things that we actually did are recorded. So the privilege policies, we've looked at this a little bit, I think, and actually in Network Plus probably. Mandatory, discretionary, and role-based access control. Mandatory is system policies to restrict access is based on confidentiality and integrity models. Rule-based, sandboxes, and implicit deny, which an implicit deny is if I give it to somebody and don't give it to you, then you're denied, you're implied deny, but that's where the implicit deny comes from. Discretionary is a decentralized system where the owner defines the permission, and it in a lot of cases is going to be in the work group model of these things. Role-based administrative control. Role-based is going to be where an administrator does most of the assignment. It's based on defining the roles and then allocating users to those roles. And in the Microsoft world, we have to use groups for that. NetWare has a role object, but Microsoft, you put users that have similar needs in groups and then give permission to the groups, and we'll look at their process here in a few minutes. Users should only inherit the role permissions to perform particular tasks. They should only inherit the role permission while they are in that role. User management. We can assign privileges directly to user accounts. But if you've got very many users, more than about 4 or 5, really, it becomes pretty unmanageable because you are giving permissions to individual users, taking permissions away from individual users on a regular basis. The process that makes it a little easier to administer is going to be group management, where we create groups, and we're going to have group objects. We have user objects and we have group objects, and we will put the users that need similar permissions into a group and then give the group those permissions, and the users will then inherit the permissions from the group permissions. We'll assign them security groups, and security is going to be an operative word because we're going to look at the types of groups here in a minute. We're going to have 2 types. One's security and one's going to be a distribution. The security groups can get permissions. The distribution groups cannot. Role-based managements, the groups reflect the roles, and again, in the Microsoft world, you're going to have to use groups because there is no role object. There are group objects, user objects, computer objects, a whole bunch of objects, but there is no role. Membership of roles may be a little bit more restrictive, and users should have permissions from one role at a time, so that you're not rolling up, you're not collecting permissions. Then we have shared accounts. Shared account be like the administrator account in Windows. There is one administrator account, and everybody that has administrative authority that has a password can use that account. The proper procedure for that, and we'll talk about the default accounts in a few minutes, is to not use that user administrator, but make individual members members of the group administrator, the administrator's group. So in the group management, we're going to have one that is administrator. Instead of having a shared account where we'd have no non-repudiation because if something is done, you don't have any idea who did it unless somebody says, yes, I did it. Directory services, directory services it's like a directory when you go into a building. You look to see where an individual is, and it's going to be a list of users and resources, and then we're going to be able to share the resources. We'll match up users and resources, who can use which ones. And access control lists are the authorizations. When we back to the discretionary access control, when you put users in, when you say users can have permissions to use a resource, a printer, print on a printer, get into a file folder or something like that, their name goes on an access control list, and the access control list says how much authority that they have, whether they can just read the documents that are in the folder, whether they can change them, how much access do they actually have, how much authorization do they really have. LDAP is a protocol that's used for the major authorization protocols. will say this, and it's where the usernames and passwords are stored. It's an X.500 standard. LDAP is Lightweight Directory Access Protocol. Uses the X.500 structure, distinguish names, attributes, value pairs, and hierarchical. It is hierarchical, and that's where we get the and we'll do that. Hierarchical, and that's where we get the distinguished names, because the distinguished names are going to be part of what we have. We have the root, the starting point, and then in this one we're going to have some containers. The containers, okay, let me back up a little bit. We're going to have two types of objects. We're going to have container objects, and we're going to have leaf objects. The container objects are just that, they're containers. I had a student one time say it's like Tupperware. You put stuff in it. And we're going to put leaf objects into the containers. And the containers are going to be at different levels of the system. We're going to have locations here. We got locations. We got organization in this thing, and we got organizational units. So, and then in organizational units we have individual objects, the leaf objects. We have the common name widget web, and we have a user in here, the webmaster. So we've got a website and somebody to control that website in here, and then we have a separate OU here for accountants and then for MIS. But what we would want to use OU's organizational units for are to break the organization up into manageable components so that we can apply different policies to different organizational units. It's just a lot easier to do it that way. The distinguished name, when we do a directory structure, we start with C:\\/ and then work our way down. In directory structure, we start at the bottom and work our way up. This is what one would look up. A distinguished name, CN, common name equal Bob Jones, OU equal IT, DC, which is domain component, Minto database, and then a domain component com. So this would be Bob Jones and the IT group at mintodb.com. They are hierarchical. When we talk about hierarchical, the full name, the distinguished name, full distinguished name, represents the location of the object in the structure here in the hierarchy. So search for directory access. We could have none. Could have simple authentication, security layer, or we could use Kerberos, TLS Kerberos. Kerberos is the one that is probably the most popular to use with LDAP. Kerberos is what Active Directory uses, what Windows uses, and Linux also uses Kerberos. Most of the databases, or most of the authentication, Kerberos and Linux are going to use LDAP. LDAP, again, is a structure, and it's a non-secure structure, so you have to create its security from something else, and Kerberos is the thing that can do it here. You can also use SSL to do those things. If you need security, you're going to disable anonymous and simple authentication. We have two levels of access to the database itself, read-only and read-write. And it should only be accessible in the private network. It shouldn't be accessible from outside the private network, from the internet. So that means that you're going to want to block port 389 on it. And we're going to validate the forms in this thing. Windows Active Directory. Now this really is a 10,000 foot view of Active Directory. There are courses and certifications in Active Directory, but Windows uses Active Directory as its database management. Active Directory, the Active Directory itself is an LDAP directory. The database is stored on the domain controller, and we can have multiple domain controllers on a network. A domain controller is just simply a computer that stores the database and authenticates users so that they can get on the network. It also stores your authorization so that we know what access a user can have. We can have and should have multiple domain controllers. Everything since Windows 2000 has been what is called a multi-master, which means that all the domain controllers can write changes to the database, can add users, modify permissions, change names, addresses, whatever else, all the components of that particular device. Then we have a domain, and a domain is a security boundary. Is what it is. We should really start with trees and forest. When we create an Active Directory, we create a forest, a large area where we can put trees. And trees generally, they can be contiguous or non-contiguous. Contiguous means they are all going to have, in this case, widget in the name. So we got widget, widget UK, and then widget US. Actually, this would have widget and then widget.uk, widget.us in these things. So these are going to be different domains, and in the same forest means they're going to trust each other. And that's what the arrows here represent. They're all going to trust each other, and that's part of being in the forest, a large area. We could create another tree out here, and these guys would still trust each other because they're in the same forest. So we have two-way automatic transitive trusts in forests. If we wanted to do isolation, we would need to complete isolation. We need to make another forest. And then if we had that, we could create manual trusts between them if we needed to share resources amongst them. And then they got OU. So we start out with a domain, and in the domain we're going to have a root, and under the root we're going to have OUs, and we should put the objects in the organizational units. The organizational units are set up to allow us to manage the different components of the network, so that all of the accountants would go into the accounting OU, and they would be managed, have policies assigned to them. And the OUs are used for policies, not for permissions. And we also have sites here. Site's a physical location. Actually, what a site is a subdomain, or a subdomain, is a network address, a subnet address. And what the site is used for is to help the users find the domain controller that they're supposed to use. We apply policies to the system. We can have local policies, which are on the local computer. You can do those yourself. If you look at the local security policy, you can create a policy. Then we have site policies, domain policies, and OU policies, and they're applied in that order. The local policy is the least significant. It's applied first. And then if we have a site policy, it's applied on top of the local. And then a domain policy on top of the site and the OU. The OU is going to be the one that wins if there's conflict among the policies. Conflict means that one of them says one thing and one of them says the other. The domain policy is the one that's going to win. It's going to be the one that will be enforced. The Active Directory root namespace is in DNS ad.classroom.com would be the name of the domain. The organizational units, administrative use, they're used to apply policies. And they say here, don't create too many root containers. It's usually that the Active Directory reads across faster than it reads down. So we can have containers in containers. We can have an OU within an OU. So we can have a tree within the organizational unit as well. Don't do too many, and you also don't want to go too deep, and nobody ever really says exactly what that is. Separate administrative and user accounts, we can do that with the organizational units that come in, that work in this thing. The other thing you need to do is document what's going on in these things. They talk about naming computer and user objects, and there's a lot of different naming schemes that are out there. We used to just name our computers, and then they started doing centralized access at the headquarters, or centralized virus monitoring at the headquarters, and they get a message that said that computer 763, for instance, has a virus. Well, we had, I think, 14 different physical locations. They didn't know where it was. So they'd come up with a naming scheme, and they came up with one that used the physical location. In Roanoke, ours was ROA dash whatever. In Virginia Beach, theirs were VAB dash whatever, so that you can identify them. The naming convention should be something that works for you. When you're doing Active Directory, it's not an organizational chart. It's the way you organize the network to make it work for the administrator. It's the thing that is going to be used to apply policies to users, and policies will be things like what can you use, how can you go, do you have to use a proxy server, what are the password restrictions, because you may have different password restrictions on different users. Up until Server 2012, you had to create separate domains if you wanted separate security policies. Now you can have separate security policies within a single domain. About administrative accounts, and this thing here, which you may, it's got pictures in the book, but what it does is applies policies. And it has things, if you can see what there, where we are right here, user rights, act as part of an operating system, add workstations to the domain, adjust memory quotas, allow logon locally, allow logon through terminal services, and on down the list here. And you notice that all those are not defined. Not defined means that whatever was set before is going to pass through this policy, but we could create a policy, we could change these, and then apply it to an organizational unit, and all the users that were in that OU and all the computers that were in that OU would get this policy. So the administrative accounts have full control over this system, and they're a user administrator in Windows and the root user in Linux. These are going to be key targets for attackers, and that's one of the reasons that you may want to consider in Windows that you, after you get the system set up, you make users that are going to be administrators and add them to the administrators group, and then disable the account administrator. You're often disabled after you install. You should do that. I think most people don't, but that would be the proper way to do it, and then give administrative authority to those users who need the administrative authority. Named administrative accounts, but control administrative privileges carefully. you can do, then we should do those. User account control in Windows, and this has been around for a little while now. The little thing that pops up and says, if it's configured by the default, did you do this? Do you want to run this? And that is a protection for us. In Linux, if you do something like that, it pops up. It doesn't say click OK. It says put in your credentials. And you can configure Windows to put in your credentials also. Although most of us want to just be able to click and move on. Don't just click it though. Be sure that you did it, because otherwise you may be installing something that you really don't want. User account management in Windows, we have local versus domain management tools. They do the same thing, kinda. They make users. Domain users have access to all the resources within the domain, the single sign-on, the authorization. They have access to everything to which they're given permissions. A local user only has access to resources on the local computer. So if we make a local user, they can't get to something on a different machine. They can only have access to resources on their machine. A domain user has access to resources throughout the domain. Group accounts, talked about a little earlier, that they do simplify administration of privileges, giving permissions for users to use resources, because instead of giving them individually to 500 users, we can put 500 users in a group and give it to them all at once. So it makes sense. And then for the detailed that you may have to use, you can use the individual users to do that. In the Windows world, we have 3 types of groups: local, global, and universal groups. And local and domain local are the same thing, except local is just on the actual local machine, and the domain local is in the Active Directory. So they do the same things. They can be used to assign rights to resources within the same domain only. So these are domain local groups. We can give permissions to resources within our local domain. Accounts are universal and global groups from any trusted domain can be a member of the domain local group. So we create the domain local group to actually give permission to the resources. And then we can put groups or users from any trusted domain. If we're in the same forest, they're going to be trusted by default, but we can put all of those into this domain local group. Global groups are designed to hold users, and global groups can only have users from its own domain, from the same domain that it's in. So that you can put users from your domain into your global groups. They can then, the global groups can then go into the local groups, either within your domain or in a trusted domain if somebody wants to give you access to resources in those domains. And then we have universal groups, which came about with, I think, Windows 2000. They can have accounts in them from any trusted domain, and then they can give permissions to resources in any trusted domain. So universal groups can have users from multiple domains to be added to them, and then they can give access to resources in multiple domains. This is the Microsoft little that AGDLP. We put accounts go into global groups. Global groups go into local groups, domain or local themselves, and then the local groups get permissions. They get access to the resources. It sounds like a long way around the world, but what really happens is once we get these groups and the permissions settled, then we can change who gets access simply by changing the membership of the global group. So it's not as around the world as it may sound. Two types of groups. I said this before, with security groups and distribution groups. Security groups can get permissions. Distribution groups are used to create distribution lists for emails. They can only be used to email. They cannot get access to resources. So there's no permissions for distribution groups. And then there are a number of built-in special group accounts. These are just a couple of them. The everyone group, the guest group, the system group. We have the authenticated users group, the network group, the interactive group. Interactive is if you log onto a computer. You get to be members of these by what you're doing. The everyone group is in fact everyone. The guest group, we can put users in that. That's where the guest account goes, and then the system is for the system. It automatically picks up. These are usually going to be processes. We have authenticated users group, which you get to be a member of by authenticating to the network, for instance. This is what an account policy looks like, and I think we looked at this a little bit last night, but we can do it again because I guess I can never do it too many times. But this is going to be a policy, a password policy, which says enforce password history, 24 passwords. So it's going to remember 24 passwords, and before you can reuse a password, you have to have 24 other ones. And then the maximum password age, the default here, 42 days, which means that the maximum is how long you can keep the password before you have to change it, before it expires. Minimum password age is after you change the password, how long do you have to keep it before you can change it again. The minimum password age, exists so that we actually can enforce password history. If we didn't have that, and a 24 is a lot, but if it was like 4 or 5, and we had a password that we really liked, and we didn't have a minimum password age, so you got to change your password. So I change it. Say my password is password, and I have 5 of them. So I like password. I want it to come back. So I make it password 1, password 2, password 3, password 4, password 5. That's 5 of them, and now I can go back with the original, and I really haven't changed anything. Keep in mind that the reason we change passwords, force password to be changed, is so that if they are compromised and cracked, hopefully by the time it takes the hacker to crack the password, we've already changed it again. And then we have minimum password length, and again, 7 characters is not what you should use. You should use at least 8 characters, because when password crackers work, they're usually going to break the password up into 2 components, and there will be 2 7-character components. If we have 7 characters and 0 characters here, this is all padding, and padding comes out to the same for all of those things. Password complexity, 4 things that you can do on the keyboard: uppercase letters, lowercase letters, numbers, and special characters. If we require complexity, and this one's enabled, if we require that, then you have to use 3 of those 4 elements. Store and reversible encryption should be disabled, should stay disabled unless you're having real issues with certain elements. And there are lots of things out there that say, oh, you got to use this for Apple, you got to use it for Linux, you got to do this, you got to do that. I think what Microsoft says, that don't do this unless you have an issues with user getting logged onto the system. So the password policies, we already did this, didn't we? Password complexity, aging, password recovery, things that we can do. Password recovery, we're not going to really recover passwords. If you forget it, the people would used to come and say, tell me what my password is. Well, you can't do that. You can tell them that you will change the password, but just like they don't know it, the administrator can't see it either. So we would need to then reset the password for the individual. And then we have complexity and aging. We talked about other things that we can control, time of day, and this is not on this policy, but it's another policy. When users can log in, what time of day. A lockout policy means that we would set it up so that if a user tries to log in, maybe misses their password 5 times in 15-minute period, we lock the account. We can lock the account for a specified amount of time, or we can lock the account until they come and say, I messed up, I locked my account. So lockout is one of the things that can slow down hackers. The administrative account is not subject to lockout. If you miss it, it'll kind of go away for a couple minutes, and it'll come back and you can try it again. Some other things that we can do here is concurrent logons. How many times can a user be logged on to the network? For regular users, we may want that to be 1. For administrators, you may want it to be multiples or unlimited, because administrative users may be logged on in multiple locations in order to be able to do their job. Disabling when somebody goes, we can disable an account. Locked is by policy. We've missed our password a number of times. Disable we do as administrator. You right click, disable the account, it can't be used. When users leave, and some people say yes and some people say no, something to consider. If somebody that has significant number of permissions leaves, you may want to disable the account instead of deleting it. And then when you hire that position, rename it with the new user so that they get all of the permissions that they need, and you don't have to go back and reestablish it. Of course, we could fix all that by doing lots of groups and just changing the group membership, which really does work pretty well. User rights, permissions, and access reviews. In the Microsoft world, and I've been saying rights, and many cases I've been using it wrong. When we can use a resource, get to a file folder, use a printer, those kinds of things are actually permissions. Permission to use a resource. A right gives us the ability to make modifications to the hardware, to the computer itself. We could change the IP address. We could add new hardware to it. Those kinds of things. So this is the long list. There's a short list which says that, yeah, we can have read, write, whatever, but this is the long list of permissions that actually goes into a Microsoft world. So as the user and the user here, and we can click change the object that we're going after, apply only to this file, folder, files, whatever. We can apply only to this one, or we can apply it to a folder and its subfolders. If you do that, then the permissions have to be read all the way down the directory structure in order to do that. We can model user privilege allocations, monitor user privileges, grant and revoke privileges. And when we grant privileges, if we grant it to an individual, permission to an individual or to a group, then we've automatically done an implicit deny and implied deny to everybody else. And revoking privileges is a matter of going back in when we check these things. This is actually an audit one, but if we check the yes, the way we get it back is go in and uncheck it. Communication between MIS and HR, who needs what, and then disabling unnecessary accounts. You should always disable the unnecessary accounts because they're just something that's waiting out there for somebody to take advantage of. if they're never coming back, you probably want to delete it. Disable those that you don't need. The guest account is one that is created by default, and by default it's created disabled but without a password. You probably want to enable it, put a password on it, and then disable it again. It's one that can't be deleted, but it can be disabled. I guess we got to the end. Understand privilege management policies. I know this was a really was a drink with a fire hose. Active Directory and Microsoft permissions are something that you normally would spend several days on, or at least several hours on, in order to learn how it actually works. If you want to play with it, you can do it on your own machine. Maybe. I'll see if I can do it on my machine. Let me bring us over here a second. We'll do a little, maybe a demo. Let's look at, we can right click on the folder and look at properties. And when we get to properties, we have sharing and security. Sharing is if I want to allow other users remotely to have this. When we share something, it means that we can access it across the network, and this one's not shared. Security is going to be the local permission. So I have authenticated users here, and what they can do. We have allow and deny, and then the system's going to have everything. Administrators are going to have everything, and users are generally going to have read, execute, list contents, read. They're not necessarily going to have write. Regular users are not going to necessarily have write permissions to these folders. We can give them that, but that wouldn't be the default. We could edit these things. These are grayed out, which means I can't change them, because when they're grayed out, they're what are called inherited permissions. They get that permission from above. They have to be changed to explicit permissions in order to do that. So permissions, when we talk about how you do it, you usually give it at a folder level. You can give it at a root level, and you normally would give permissions to a group and not individuals. This is just a PC, so the group management's really not necessary for it. So let's look at some questions here for a few minutes. Let's go ahead and do this one. Secure network designs is where we want to go with this one. The objectives describe the use of zones, DMZ, and layered security, defense in depth, to plan network security. Know how subnets, VLANs, and NAT can be used to improve network security, and identify security considerations for network devices, switches and routers, for those things. So the secure network topologies. The topology, as we found out in Network Plus, is the physical or logical layout of a network. We can have a physical one thing and a logical something else. We can have a logical bus and a physical star, for instance. And then subnetting, the thing that everybody loves to hate, is a subdivision of a larger network. What we're doing is taking our larger network and breaking it down into smaller components. It gives us more broadcast domains. It's also going to give us some isolation, because it becomes a little bit more difficult to go across a router instead of just being able to see everything in one big pool. We've got to find out what area, what zone it's going to be in. And so the subnet compartments the traffic. It keeps the traffic, broadcast traffic, most traffic within an area. Now switches do that at layer 2. subnets do that at layer 3. Zones are areas where all the security configurations are the same. We have security zones, and we control and strictly control traffic between these zones. And when you get into when you're actually managing these things, depending on the type of system you have, you assign zones priorities, and you have to have a certain priority to go from one zone to the other. We can also do it with filtering to prevent access across a network. Then we have the private network, which is our protected network, the one that we're using, that our users are on and our resources are on. An extranet is where we would allow a different company or users from a different company access to some of our resources. And then the internet, of course, is the internet. It's the unprotected wild, wild west, where in some cases anything goes, but the internet is considered the unprotected network. The private network is the protected network, the untrusted network, actually. So we have a trusted network, the private network, the internet's untrusted. Extranets, we establish a trust with somebody else. And then we're going to have a DMZ, which is going to be a semi-trusted. So with secure network topologies, in this case, we have firewalls here to protect our internal resources. This thing kind of sort of shows what we do. We have a public web server and an extranet application server. The internet, it shows it connected. There should be some sort of a control here. Probably maybe a filter router to do that. And with the filter router, the public web server, we're only going to need like 80 and 443. So we could make an access control list on the device that we just put in here that only allows traffic to this IP if it's going to those ports. Everything else it's going to reject. The extranet application server, we'd have to look and see what ports, for instance, or what filtering we needed on it, because I don't know what resources are running on it. Key here means we're going to have to authenticate to it. No key on this one, no authentication. Anybody can get to the website, and generally you want anybody to be able to get to the website. Firewall here hopefully is going to protect the rest of it. We're going to reject probably all connections that come into the firewall, and we'll talk about firewalls in the next unit, or in the next unit. The network server, the application server, and our clients all are over here in our protected network. In general, the firewall is going to allow certain traffic out of it. So what we configure here is a semi-trusted area. We have an untrusted area of the internet. Semi-trusted is going to be the DMZ, and we're going to talk about them in just a second. And over here is going to be our trusted network, our private network. The demilitarized zone, in it we have it is a semi-trusted network. We have a host in it, is facing the internet facing. It's through a firewall here, but it is internet facing. The DMZ is an area where we have some filtering typically, and this one we're using a firewall. We could use a firewall or we could use a filter router, either one. Bastion host here in the DMZ, this is a server that's sitting out here for some particular service. It could be a web server. It could be a proxy server, for instance. We'll talk about proxies a little later on too. But we have this server here which is protected to some degree. Bastion host means that we're going to have turned off all the services that aren't needed. What I think the book says, a bastion and a castle was an extension of the castle that was well defended. So what this device is going to be is well defended. But depending on what services we have, and you remember back to the TCP ports represented services, so we can only allow connections to be established through the firewall to those particular ports so that we can provide the services that we need. All the other traffic to our internal network are going to be refused at the firewall. That's why we have these things. So we again have protected the trusted network. We allowed access to the semi-trusted network, and when we let our guys out onto the untrusted network. A proxy server is something that does something. A proxy is something that does something for you. A proxy server, a web proxy, if we used it, if we'll pretend that this is a proxy server here, these guys go to HTTP, whatever, it goes to the proxy server. The proxy server then deconstructs the HTML request. And when it does that, it may find some issues, it may destroy some issues with that packet. It then rebuilds the packet and it goes to the internet to get the information. So the machine back here never actually directly connects to the internet. The answer comes back to the proxy server, does the same thing, deconstructs the packet, may find a virus or whatever, and we'd be able to destroy it here, and then sends the information on to the machine that used it. The other thing that proxy servers do is they can be caching servers, so that they can actually, if you go to a website more than once, it can actually speed up the connection to it. Although in today's world, their connections are pretty good. Extranet and internet, intranet likely are internet facing. An extranet is going to be probably in the DMZ. One of the things that we want to keep from happening is connections back into our private, our trusted network. Public access to the DMZ can have a screened firewall. This is a screened firewall, or a screened subnet up here. It has two firewalls. The other way we can have is a three-legged firewall, where we have a device that has a DMZ capability, a firewall capability to protect our trusted network, and a public-facing interface. So we have a three-legged firewall here. Problem is single point of failure, although these up here are single points of failure also. All of these things are single points of failure. The thing that would happen here is if this device gets compromised, we've compromised our DMZ resources as well as our private network. In this one, you'd have to compromise both firewalls in order to be able to get to the private network. And what we're trying to do with all of this protection here is to protect the private network, to keep our information secure, and to allow the users to have access to the public resources that they need. Screen host is for smaller networks without the technical expertise, and it may be a dual-homed proxy. We have a router firewall here, and then we have the screen host, the dual-homed computer at this site. Dual-home computers can be dangerous. This one's behind a firewall, but if it didn't have a firewall, if it were on the internet, what you've really given is a path across this thing to your network. So if you use dual-homed hosts, be careful about them. The screen host here actually is screened, so it's not as big a deal. We have a router firewall at this location to protect it. Again, the smaller networks may not have the technical expertise that's required to run all of the multiple firewalls. When we talk about home office machines, the routers there are not going to be nearly as complex as the other ones that we use. Other security zones, we can map the zones, and this shows map the zones to the business needs. We have access accounts domain here, the intranet at this location, and this has an external interface, a firewall here, and then we're protecting our resources with another firewall. Tunneling is another way to provide security. We always show these really cool tunnels that it goes into, like it has a direct connection. But remember, when we go across the internet, we have routers to go through. What this really is an encrypted packet with an unencrypted IP address or an IP header on it. These VPN firewalls create the connection between here, and then when traffic gets up to the firewall, if it's destined for this network over here, its address, it gets encrypted, gets a new header put on it, and it gets sent directly to this address, where it's then the header stripped off and is decrypted and sent to this network. Remote host configuration can be an issue, and a remote host configuration would be these guys back here. Well, let's pretend that this is a single one and we're connecting to our network. Remote host, somebody working from home, for instance. What's the configuration on that machine? Does it have any viruses? Does it have antivirus software? All of the things that we can ensure happens on the network, we need to have some means to trust the individuals that are getting onto the network. We're going to talk about layered security, security in depth, with perimeter security. We have an inside perimeter, a firewall, IDS scanning, network access control, all the different things that we're trying to do to keep the bad guys out, and to be sure that when people get in, that they have the protections on the machine that we want them to have, like it's up-to-date Windows software, and that they have an antivirus, those kinds of things, firewall enabled, whatever we do on those. The perimeter security would be what we do out here with the external firewall. The internal perimeter would be the internal firewall or internal router that we use with these things. Network device exploitation, we have those things, switches, routers, so on. We use remote management. If we use remote management, then we have exposed it to the possibility of being compromised. Privilege escalation is one of the things that users or that hackers are constantly trying to do. Weak passwords. Users may not make good passwords. There are softwares available if you want to do that. If you want something to create a password for you, they'll make some pretty good ones. Backdoors and default accounts. The default accounts should be disabled. They're the ones that shouldn't be left constantly running, constantly available. Backdoors may be from a Trojan or something else, or it could be a backdoor that the manufacturer put in. There are those out there. There used to be, and I looked for it, not very hard, but I looked for it, a list of backdoor usernames and passwords for Cisco devices available on the internet not very long ago. So those things are out there. They've mostly taken those kinds of accounts off, but they're not entirely gone. Denial of services on these things, we can do that, the routers, by maybe getting a false route into the router, or packets, the SYN, the weaknesses in the SYN, those kinds of things can do that. Physical access device exploits. If you can get physical access to a device, you just basically own it. If I get physical access to a Cisco router, for instance, I can change the password on it in a couple, 3, 4, maybe 5 minutes, and then I would own the router. So we want to physically protect these guys in order to be able to make the whole system more secure. Because if I have physical access, I can change the route and send the information through whatever I want it to go in order to filter it. So physical device exploits are a big deal. You can do the same thing with a Windows machine. You can boot to the Windows CD, DVD, and actually create an account before it logs on and make yourself an administrator on the network. Hubs and bridges, I think we've talked about these in the Network Plus portion of the program, but in the beginning, when we started sharing things, there were buses. And then after there were buses and repeaters, we had Ethernet hubs, which were multi-port repeaters. They operated at layer 1, and all the traffic went out all the ports. So everybody got everything. We could sit out there put our NIC in promiscuous mode and see everybody's traffic, which meant that everybody's traffic was being exposed. All the ports were in the same collision domain, so that if we started getting a number of machines on a network, collisions would increase, and collisions would increase would slow down the traffic, all those things that we really love to hate about networking. The bridge divided, overloaded Ethernet segments. What it did was to only send traffic on the other side of the bridge if it went to a device on that side of the bridge. It kept a table of MAC addresses, knew which side that each MAC address was on, and so when the traffic got to the bridge, if it was on its side, it just ignored it. It just didn't send it. If it was going to something on the other side, it picked the traffic up and sent it to the other side. Switches became multi-port bridges, and switches created a collision domain on each port. They improved performance dramatically because we don't have collision on switches. We don't see other people's traffic on switches. They also improve security to a great deal, to a great extent. They can be compromised. We can do MAC flooding, those things like that. But the switch is the one thing that really helps us out from a security and performance standpoint. I've said several times, I think, that not in this class, but in other classes, if I could only have one device to improve my network, it'd be a switch. If it'd be a layer 3 switch, it'd be even better, but a switch, because it speeds up traffic. It gives us some degree of security when we put them in. Switches and VLANs, the uses for switches, we've switched Ethernet, and those are the ones that we use in order to create the micro-segmentation of the network. We have VLANs, virtual local area networks, where we basically break the switch up at layer 2 into layer 3 segments. I'll say layer 3 segments because it requires a router in order to send traffic from one VLAN to another. A VLAN is actually an IP subnet, and it shares information with all of the other machines on the same VLAN, the same IP subnet. In order to do that, we have this thing called a trunk port that takes traffic from any of the VLANs. So we have here VLAN 10 and VLAN 20. If I were going from a machine on 20 to a machine on 20, I go in here, go into trunk, and the trunk, when it gets in the trunk, it's going to be tagged as VLAN 20. It's going to go down here, and then this guy's going to send it back here. When it gets to this switch, the information is only going to go to the VLAN 20 devices. VLAN 10 is going to do the same thing, so they can talk back and forth across the trunk port. If I want to go from VLAN 10 to VLAN 20, in this one I can't do it because these are all switches. I need a router in order to do that. So virtual is a layer 2 broadcast domain configured through a switch. The devices on separate VLANs must communicate via a router. Trunks, and this image down here is designed with colors. Find my pointer. With colors here that we have different colors for different VLANs. The trunk port has all the colors. It has all of the VLANs in it. When a packet goes out of a switch, it's tagged. When it goes into a switch, the tag's removed and is sent to the proper VLAN. This little guy over here is called a router on a stick, and it has a trunk port going to it. So if traffic were going from VLAN A to VLAN B, it would go here, go into the router, out of the router, and then to VLAN B. So it can be used in order to, or it is used in order to allow traffic between the virtual local area networks, the different IP subnets on this thing. Switch vulnerabilities and hardening. The vulnerabilities are MAC flood, ARP poisoning, and then VLAN hopping. And VLAN hopping is when we have these things, we have a native VLAN, and the native VLAN is for untagged. What we would do here is to put 2 VLAN tags on it and get it into the native VLAN. Once it gets there, it gets into the switch. The first tag is stripped off, which leaves us the second tag. It's then sent to the VLAN that tag represents. VLAN trunking protocol is used to, VTP is used to establish trunks and to share information about the information. The trunking protocol can be an issue because if it's set up for auto negotiation, we can create a trunk on a port that we don't necessarily want a trunk on. And then spanning tree, denial of service. Spanning tree is used to allow us to have physical loops by disabling one of the ports and breaking the loop, so that if something happens in our system, we can then bring that port up and continue to communicate. Spanning tree creates what's known as a root bridge, and the root bridge is kind of the place where everything's going to eventually go. The problem with the root bridge is it has an election, and it uses the lowest MAC address as the root bridge, which means it's going to have the oldest machine. But what the spanning tree denial of service does is we inject information into the network so that our switch gets elected as the root bridge. So talking about countermeasures for this, we can do port security. Port security is where we configure access ports, the places that we plug our machines into, so that it only accepts a limited number of MAC addresses. If you only have one computer plugged into it, there's no reason it shouldn't accept any more than one MAC address. That way, if somebody unplugs our machine and plugs theirs in, it just shuts down the port. A secure management interface, which means we're going to use encrypted interface. Instead of using FTP, we use FTPS. Instead of using Telnet, we use SSH, those kinds of things. VLAN configuration, using VLANs and sending have dark hole VLANs for things like the native VLAN. If we're not going to use it, if we don't have anything that can put untagged packets in, and that would be hubs, then we can send it to a dark hole. And then you want to be sure that you update your firmware regularly, and that's the case with everything. We want to do regular updates on all of our systems. Sometimes these devices, firmware updates, are not as easy as Microsoft, because Microsoft pushes it out to you. They want to be sure that you're doing updates. Cisco, you have to have a maintenance package to actually be able to get those on a regular basis. So, but you do need to update everything. Bridging separation. If we misconfigure a bridge, we have a wireless NIC and a wired NIC, we could actually inadvertently set up a connection to our private network. So malicious or accidental, the devices allow two networks that should be separate to communicate, the internet and our private network, because for some reason we created a bridge between the wireless network, the wireless NIC, and the wired NIC. Some people think that it's going to make things faster, but it probably won't. It may even create a loop and slow you down. What I've found with Windows in particular is if you have two NICs and both of them connected, sometimes it gets really confused and doesn't know which port to send it out of. So if you have multiples and you're only using one, you may want to consider disabling the second one. VLANs, access points, client network adapters. This is the Wi-Fi to internet if we have this thing improperly configured, an improper separation. If you have something that really needs to be secure, it may be physically disconnected from other networks. It's called air-gapped. That it's air-gapped. It's not allowed to communicate with the rest of the network. Routers are layer 3 devices. We have routers that route in software and layer 3 switches that switch based on IP address and hardware. So if you have a layer 3 switch, it's A, going to have more ports, and B, it's probably going to be faster. But the layer 3 devices can be used to subnet the local network, create networks in and around it to separate traffic. It does help when you, not only from a security standpoint, it helps your users because there's going to be a whole lot less broadcast traffic instead of having one great huge network. And it also hides to some extent the other machine from users that may be trying to do something that's not so nice to them. We route between the external networks with border routers. Border router would be one that goes to the internet. These things keep track of multiple paths, and they select the best path. That's the traffic management. They select the best path to get from point A to point B. They frequently support remote access, facilitate remote access. You can generally create a VPN on a router. An edge or a border router does protocol conversion, converts our Ethernet to whatever our WAN protocol is. So they're very flexible devices that help keep the network secure and get the traffic to the correct location. This is a router placement. Where do we want our routers to be? In this case, we have a WAN router. This one goes to the internet, the one that's going to translate the Ethernet to whatever protocol we're using here, probably point-to-point protocol, or maybe one of the Cisco proprietaries if we're going from Cisco to Cisco. I talk about proper router placement, and in this case all we have are switches. If we have these different VLANs, then we're going to have something to route between them. And this one just showing VLAN 10s onto two different switches. That would then allow it to, they could communicate via a trunk port here and be able to communicate from one machine to the other. And then a wireless access point plugged into the switch, so it gives the wireless clients access to the wired network. And then they can go on through to the internet. If this is set up trunking here, then it can be used to route between these VLANs. So we can use a router. They can be configured as having a trunk port coming into them and having all of the different VLANs and then route from one to the other. You may have internal routers, external routers, and internal routers. And typically you're going to have external routers and internal routers on the network. You're going to use what we used was we had a filter router, firewall, and then from the firewall we came in and went to the internal router, which was actually a layer 3 switch that distributed the information within the network. So we had several layers of filtering that we used in order to limit access from the outside world, actually stop access from the outside world. Routers, routing protocols, we can either do static routes or we can use dynamic routing protocols. Static routes are configured manually by the administrator, and if you're only going to a limited number of locations, for instance, we keep showing this single router going to the internet, which is actually going to the ISP. There's only one route here, and everything going to everything on the internet is going to go to the ISP. So we can have a static default route that says send all of our traffic this way if we don't have a route for it internally. So we can do those things. Dynamic routers exchange routing information. We're using different protocols. Open the shortest path first, RIP, BGP, EIGRP are all the letters that are routing protocols. So these things share information about routes. What they really do is tell you what they know about locally, and that's the only thing originally that a router knows about is all of the locally connected network addresses on it, and it then shares that information with others, and they share it depending on which protocol we're using will make it more or less efficient. OSPF is one that builds the entire network infrastructure in its memory and keeps it, and then it keeps backup routes also. RIP just simply sends the entire route table every time that it updates. So it's going to, I think it's every 60 seconds or 90 seconds broadcast. So it's going to put a lot of traffic out there. BGP, Border Gateway Protocol, is what the internet runs on. It's a WAN, a wide area network protocol. So, and it's similar to RIP, but it doesn't get all the information nearly as quickly, because you can imagine how many routers go up and down on the internet on a given day. This image over here is what a Windows routing and remote access server looks like, a Windows router looks like. They're pretty easy to configure, but OS routers are not nearly as efficient as devices that are designed to be routers, because a router is a specialized computer, is what it really is. And a Windows machine is a generalized computer. It actually is designed to do other things. For routing attacks, we can use fingerprinting, can reveal the presence of a router. And we looked at fingerprinting last night using Nmap, or actually ZenMap and Nmap, where it gave us the ports, and in some cases can identify the operating system that's running on it. Could be software exploits in the underlying operating system, and routers have exploits just like Windows has exploits, Cisco has exploits, Apple has exploits, Linux has exploits. So those things, the iOS, the reduced instruction set does give us a reduced attack surface, but they are still exploitable. Could be spoofed routing information, use route injection, where the information gets sent to where we want it to go, the hacker want it to go, rather than where we, the administrator, want it to go. Could have denial of service attacks on these things, redirect traffic into routing loops or black holes. And if we go into a routing loop, since we have a time to live at layer 3, the packet will eventually die and it'll just go away. Could use ARP poisoning or ICMP redirect. ARP poisoning for a man-in-the-middle attack. ICMP redirect tells it to send the traffic on a particular route, and the particular route would go through where somebody would be sitting monitoring the traffic. Source routing can be used to spoof the address and bypass a router. What the source routing does is tells the computer what route to use. And you could have vulnerabilities that cause buffer overflows. There's lots of things, and most of this is not going to happen to you, particularly if you're paying attention to what's going on and take care to do the things that you need to do. Network address translation, I know was covered in Network Plus, but let's go through it quickly. It translates a local address to a global one or to a routable internet address. Remember, the private addresses that we use on our network are not routables. The 10s, the 172s, and the 192s are not routed on the internet. So what we do in an attempt to save, or have done in an attempt to save on IPv4 addresses, is we've come up with schemes to make it more effective. Proxy servers are one, because all of our machines could go through the proxy server and we only need one IP address in order to operate it. NAT allows us to translate, and NAT itself is a one-to-one translation from a private IP address, an inside local address, to a public address, an inside global address. The insides are what we use, the terminology, and this is the Cisco terminology: inside local and inside global, outside local and outside global. The ones that are on the other side of NAT, the router, are the outside global and the outside local. What we would use the outside one to be to map or to NAT a public IP address to a private. So you can go both ways. You can NAT private to public and public to private. One-to-one doesn't really save us a whole lot on IP addresses, though. So what we do in many cases, it's what you and I do with our routers, we use port address translation, where we have a single IP address and we have multiple ports to connect to that. Because if you remember, an IP address plus a port gives us a socket, so that actually gives us a location, a place to come back to. And we're going to have a slide on that in a second. But dynamic NAT, instead of using static one-to-one mappings, uses a pool of addresses, and we create a pool, and then we tell which private addresses in the Cisco rules, in router rules, which private IP addresses can get NATed to public IP addresses, and it takes the next available one out of the pool. Issue here is we may run out of addresses if we have a lot of our users need to get on the internet. To do that, we can use an overload, a net address port translation. And what we can do if we use NAT, if we run out of addresses, we can use a command called overload to actually shift from a one-to-one to a port translation. So what this thing does is we connect to 10.0.0.1 to GTS learning at the 77. It goes through the firewall. It goes through the NAT device, and the NAT device is going to give it a port. We do a single IP address with a specific port. So it's going to this address, comes to the port address translation. It uses port 60,101 for the 217.4.253.5. 253.5, open connections for this, and send it to the web server. When it comes back, it's mapped now to go back to the correct location. So instead of using a one-to-one IP address, we use a a single IP address for everything, and we separate the connections by using port numbers, high number port numbers for those systems. This is a destination NAT and port forwarding. Destination NAT and port forwarding is what we would use on a home office, small office, home office router. You usually have the ability to, well, you do have the ability to send particular ports to a particular private IP address. It's similar to NAT. We have a single address comes into our machine or comes into our router, and then if it's going to port 80, we send it to 192.168.1.3, which is here. This is showing all the services running on 1.3. We could have different services on different machines, but we can only redirect a port one time on these things. And this would be similar to the outside in NAT. It's going to allow users to access resources on inside the network. So the use of zones, describe the use of zones, DMZ, layered security, defense in depth to plan network security, how subnets, VLANs, and NAT work can be used to improve security, and identify the security in considerations for the network devices, switches, and routers. So we get to try the questions again. Anybody going to help Derek and Kevin? Why is subnetting useful in secure network design? Go ahead, Derek. You're the only one playing.
I practiced that answer too.
Huh?
It's something about a sniffer or something when I was reading that. Let's say it. Subnetting, right?
Subnetting, yeah. What does it do to help us?
To make it harder to sniff traffic, right?
Yep, does all those things. It kind of can hide the traffic. Is rather allowing it to be filtered by devices such as firewalls, so that we can keep attackers out, hopefully, and keep. The other thing that firewalls allow us to do is keep our traffic in, so that our users can't become a member of a bot army. So you can filter stuff at the firewall that can't get out, and you don't become part of a denial of service attack, for instance, or something like that. What is the purpose of a DMZ?
That's so traffic can now pass through it.
Yeah, so we want to allow everybody to get to. If we had a website that we wanted people to get to find information about our company, we'd want that in a DMZ. You want everybody to get to it, but you don't want them in your private network. How can a DMZ be implemented? There they are. There's a number of ways. Could use the two firewalls, a screen host, the three-legged firewall. What technology would you implement to protect part of a network against packet sniffing? What's the one device that helps us out? If you could only have one device, what would it be?
I would say firewall, but never mind.
If I could have one device, it'd be a switch. If you sniff on a switch, what traffic do you see? See it to you and the broadcast traffic. True or false, administration and configuration of a switch should be limited to default or management VLAN.
True.
Kevin, the first one was, first word was default. And no.
Okay.
Don't mess with it, yeah. The management VLAN is for trunking protocol traffic only and should otherwise be unused. It's a good idea to use a dedicated VLAN for the network device admin, though. You can put it on its own VLAN. Or if you're all right there, you don't have to make it remote managed. If you have all of your stuff right there in the NOC, you may not need to do that. Because that's the only reason you need an IP address on a switch is to manage it. Because it's not going to do a whole lot of any of the other stuff. How could you prevent a malicious attacker from engineering a switching loop from a host connected to a standard switch port? What I didn't talk about is if we, in a VLAN trunking protocol, and I should have, if we don't have it properly configured, if they're set up for auto negotiate, then you plug a switch in and I get all of the updates from the network, because it also will send all the configurations and I'll have all the VLAN information. What I do then, since I'm on a trunk, is I just put my port into the VLAN that I want it to be in, and it goes on the trunk, and then now I'm on that VLAN. That's one of the ways to do it. You've got to configure the ports. You got to configure port security on these things. What technology would you use to enable private addressing on the LAN and still permit hosts to browse the web?
Ain't that, is it?
NAT. Yeah. What steps would you take to secure a network device against unauthorized reconfiguration? I lost where I was. Against unauthorized reconfiguration. That one is enable a single management interface or protocol, preferably encrypted. Secure the administrative account with a strong password. Set up an access control list. Update firmware when necessary. If the device has an external internet-facing interface, restrict access to the management console to a management subnet. That's a mouthful, huh? Questions? I think there's only two of us here. Let's take a break until, let's go to about 10 minutes past the hour. We've got one more module to do tonight. So when we talk about security appliances and applications, and firewalls are the thing that come to mind when we talk about these things. There are other ways to do it, firewalls being one of the primary, or the primary tool to start in our defense in depth of the network. So the objective is know the types and features of network and application firewalls, proxies, gateways, and security appliances. Implement and configure security appliances and applications. Describe the types and features of intrusion detection systems, and we really would like to have an intrusion prevention system here. Understand the importance of configuring and monitoring secure audit logs. So we'll start out with firewalls, and the objective of a firewall is to restrict the traffic allowed on the network. It filters. It allows the traffic out that we permit and allows the traffic in if we permit any in. Used to implement the security zones that we talked about. We can filter traffic from zone to zone. For instance, if in your accounting where they have the payroll database, you're probably not going to want to let a whole lot of ordinary users, regular users get into there, but you still need to let the accountants get out to do their job. They're configured with access control rules which we either permit or deny. And at the end of, and we'll have something here a bit later, but at the end of the access control list is generally going to be an implied deny all, which means that you need to give at least one permit statement in an access control list or you wind up denying everybody everything. The types, there are many types, many types, and where it is placed is going to be part of what is going to determine that. What does it inspect? If we're going to have, some of them do deep packet inspection, some only look at the header. So where is it? What does it do? Most of them do NAT or PAT, so that we can do that with these devices. Well, first type is packet filtering firewalls, and they inspect the header of the packets at layer 3 and layer 4. We have the source and destination IP address and the port number, UDP, TCP, ICMP routing protocols that we can filter on these things. Source and destination port can be done. We can filter on it either depending on whether depending on the type. We'll just say we can do that. And we can look at inbound and outbound traffic or both. And the terms you may see for those are ingress and egress. They're rule-based access control lists. Simple, fast, and inexpensive, but there's a lot that they don't do. And when we look at these access control lists, what happens in the system is it starts at the top and works its way down. The packet does, am I this, am I this, am I this, and it does the comparison until it finds something that fits. When it finds something that fits, it executes that rule and doesn't go any further. So the more specific rules in the access control list need to be at the top of the list. For instance, you wouldn't want to put the permit any before you denied a specific IP address. So what we would want to do is deny IP whatever. And if that was the only thing we were doing, then we would do permit any, permit anything else. And then after that, we would have the implicit or the implied deny all, which nothing should get there because we had the permit any before that. The problem with, and we'll go back to this one in a second, the problem with the packet filtering firewalls is they don't have any idea about the state of a connection, of any connection. So all they do is filter it. may make it difficult to bring your traffic back because you're inspecting the traffic. And if you haven't permitted those ports, for instance, then the traffic can't get back in. So you may have to permit a lot of high-numbered ports in order to get the traffic back. These are generally going to be older firewalls. What most firewalls are now are stateful inspection firewalls. What they do, it says they're circuit-level stateful inspection firewalls. They can examine the headers, but they keep a state table at the session level. What that means, a state table, is that when a query goes out of the stateful firewall, it goes into the state table. And when the answer comes back, it gets matched with the outgoing traffic and sent to the correct location, so we don't have to worry about filtering the answers to the questions that go out. So the arriving packet's checked to be sure that it actually is part of that it's not a spoof packet, that somebody's not trying to do connection stealing or something like that, and then it's sent back to the originating requester for that particular information. We can also apply the packet filtering rules here. We do apply packet filtering rules. What can go out, what can go in. The advantage to this thing is it keeps track of the state of the connections. It knows about the connections that originated from inside and allows the answers back into the network. It has better protection against the denial of service attack, has flood guard checks, and checks the TCP three-way handshake to see if somebody's trying to do a SYN attack on it. Monitors the packet sequence numbers so that somebody can't try to simulate those or counterfeit those and steal that connection. So by doing this, we prevent session hijacking and can block source IP addresses. Source IP routing these are better than the the old-fashioned ones. The packet filtering, what we really want are stateful inspection firewalls. Most firewalls today are going to be stateful inspection. Then we have these application-aware devices, and they inspect the packet contents, which is going to allow us to have even more security on the network. I used to do a lab in a security class where we did a DNS spoof, where we did DNS redirects and would send from one place to the other, and then the headquarters where all of our traffic went out, put in one of these new firewalls which looked into the packet, and even though we had done the DNS spoofing and had the right sending it there, it looked into the packet and said, oh no, I see where you wanted to go and that's the wrong IP address for that, so it fixed that. It was a Barracuda firewall. It did an awful lot of stuff. So we have the ability to make the networks more and more and more secure. Problem is still going to be the people. Somebody that clicks on the email that they shouldn't and creates a backdoor for you. But it can examine the packet payload and monitor the connection, so it is a stateful device. It requires a filter, a different filter for each application type: HTTP, HTTPS, SMTP, POP, IMAP, FTP, on and on and on. And all of today's firewalls, except the cheapest, are going to be stateful firewalls. The other disadvantage of firewalls is they can't see encrypted packets. So the encrypted packets just go straight through them. If you want to have something in private, that's the way to do it, is send an encrypted packet. So they can't see those, they can't filter those. Proxies and gateways. A proxy is something that does something for you. If you have a proxy, they act on your behalf. packet filtering firewall forwards or blocks, they either permit or deny the packet through the firewall. Proxies store and forward. That means is they go there, they stay at rest even if momentarily on the proxy server, and then they're sent on. It does break the end-to-end connection between the host and the internet. What happens is we send a packet to the proxy server, and depending on what kind it is, we'll say a web proxy, an HTTP packet. It deconstructs the packet to see if it complies with its rules, and we can have a number of rules on there. We can deny or permit based on keywords, based on IP address, based on web address, on and on and on. But one of the issues becomes in the keywords, if we were filtering out the word SEX and we try to go to ESSEX England, then we would be denied because it'd see that character string and stop it. It wouldn't comply with the rules. It can also, in many cases, stop viruses and in some cases, intrusions. It opens the connection with the server on behalf of the client or vice versa. What it does is after it deconstructs it, it rebuilds the packet and sends it out on the internet. So the actual traffic to the internet comes from the proxy server. It does a couple things. One of the things that it does is hides our internal IP addressing scheme. It's because all the traffic comes from a single address, that being the proxy server, which is also going to conserve our IPv4 addresses. These things actually are a man in the middle, and we can have a transparent or a non-transparent proxy. A non-transparent means that in the configuration of your browser, you put in the address of the proxy server and the traffic gets sent there. A non-transparent, it actually intercepts the traffic and proxies it so that people don't know that they're going through a proxy server. Most can cache and prefetch content, so it may speed up the system a little bit. One of the things that I used when my son was a teenager was a proxy server because I had trouble getting him to go to bed. So what I would do is turn his machine off, his IP address off at his bedtime so he couldn't get out. He was really addicted to AOL Instant Messenger at the time. What I had to do was shut down AOL Instant Messenger, turn his IP address off on a proxy server, and then he couldn't reconnect because even if you turn it off, existing connections aren't affected. So you had to make that connection go away and deny him a new connection. Non-transparent, transparent proxies, whether we have to actually put the IP of the proxy into the configuration of the browser or not, goes there. Reverse proxies can be used to give access to resources inside the trusted network without actually allowing users to get into our private network. It works the same way, except it doesn't go from outside in, it goes inside out. It goes from outside in, from the internet side back through to the private network. Proxy servers are protocol specific. We can have HTTP proxies, FTP proxies, messaging proxies, on and on and on. And a web proxy is called frequently a web security gateway. It does protect us. Connects to a single point, in this thing we've talked about this before in the last slide, connects to a single point for web traffic. It has a caching engine so that the second time you go to the sites should be much faster. And we have transparent and non-transparent reverse proxies for inbound traffic that allow access to the internal network. In implementing a firewall, and this is a control panel for a Cisco PIX, they've gone more and more to GUIs because when you write firewall rules, you configure them on these interfaces here, and you say apply it. They frequently write somewhere between 150 and 200 configuration statements. So you really do need these in order to help you configure the firewalls. There's no one way to do it. For a network, we have an appliance, could be a standalone or an all-in-one, an all-in-one, a UTM universal management system. Could be a router, part of the firmware layer 3 switch, or the operating system on a software on a server. Keep in mind that the dedicated devices are going to be more efficient at those purposes. The operating system on a server or on a client machine is not optimized for routing and firewalls. It's optimized to do applications and things like that. And we can have host-based, an application firewall on a server to protect a single application. And then we have the personal firewalls. Personal firewall, Windows firewall, which has gotten a lot better. The personal firewalls have tended in the past to focus on applications, whether they're allowed to get off of the computer or not. The Windows firewall, the advanced firewall, has a lot of configuration capability that you can use to filter on services and ports. Configuring, we're going to use rule-based management, and when you do these things, when you're trying to write firewall rules, don't try to do them all at once. Do them one at a time and go through a process. Write it in English. Allow all my clients to get to the proxy server or to get out with HTTP. Write the rules in English that you want to happen, and then write the specific addresses and ports to permit or deny. Then after that, write your firewall statements. If you try to do them all at once, and do them one at a time, and the first time you do it, the first time you write them, don't try to do them all at once. Make one rule work. Once you make one rule work, you've got the template. The process is the same for all of the statements. It's just what you put in, what IP address, what port number, those kinds of things. Access control list, it shouldn't allow private IP addresses in or out of the network. There's certain protocols that you may want to block. Pen test to confirm that it works. You're going to usually know that it works or doesn't work, or you're going to know if it doesn't work, because your users will let you know very quickly if it doesn't work. And then protect the hardware. What we want to be sure is that we keep all this stuff locked up, because if we don't, somebody's going to do something really nasty to us. The implicit deny is at the end of all of the statements in an access control list. And then flood guard to prevent packet flooding in the systems. Host-based firewall, protect a single host, a single computer, yours or mine. Windows firewall is one of those. Can perform filter, and it usually does based on program or process. It's typically program or process based. The first use of the program, block or allow, you click on the program the first time and it says, do you want to allow this program to have access to the internet? And you say yes or no. So we do a block or allow on the first use of those things. The host-based are kind of vulnerable to tampering, so you need to be aware of those kinds of things. But they are being improved all along. The original firewall on Windows really wasn't all that good. The one that came out recently that had the advanced firewall is pretty good. It can be used. So we have web application firewalls are designed to block HTTP threats, not threats. They're able to, they look inside the code and they look for matches on suspicious code and out of a vulnerability database. They're looking for cross-site scripting, SQL injection, and distributed denial of service, those kinds of things. You can do outbound filtering. We always think about what we're trying to keep people out of the network through perimeter defense, but outbound filtering or egress filtering can also be significant. Prevent data theft or people sending it out. It also can prevent you, by blocking certain ports, can prevent you from becoming part of a distributed denial of service attack, for instance. So you can block all the ports except the ones you need. If your users only use the internet, you could actually block all the ports, set a proxy server in the DMZ, and block all of the outbound ports except for the one that goes to the proxy server. You could make everybody go to the proxy server to do their thing. But then you'll get the management, the higher management saying, oh, we don't want to use a proxy, we want to be able to go directly. So then you wind up having to allow more ports to be open. Web Security Gateway, this is a lot of applications, and they do this on purpose. A lot of applications use port 80, a lot of applications use port 443 because they can wrap their application in HTTP, and the port 80 and 443 are normally open all the time. So, and blocking 80 is not an option, but could be allowing access to many applications, and the Web Security Gateway is going to watch for those. It's for corporate control of internet use, what goes out, what comes in, and it again is one that can be based on keyword or URL based filtering, time of day. What do you want to do? One of the places I worked, we actually did that, and what they did to keep the security guards moving, or hopefully moving, in the middle of the night, they're supposed to be patrolling, instead of doing on the internet, they got like 15 minutes or 10 minutes an hour for their 10-minute break of internet time. So they had time of day restrictions, and you can do all of those things. These can be are a combined firewall, malware scanner, IDS, all-in-one appliance, or proxy, and the UTM, Unified Threat Management. And that's what a lot of devices or a lot of people are going to, or Unified Threat Management. And I think that probably that's what the Barracuda firewall is. It's not just a firewall, because it does deep packet inspection. It sees what goes out, what comes in, and can look at all of that traffic. SMTP, POP3, and IMAP. SMTP, Simple Mail Transfer Protocol, is the sending application. It's what we send email with. It's what email servers use to send traffic from one to the other. It routes mail between servers, uses port 25. It also is the thing that spammers look for. They look for what they call an open relay host. They're looking for an SMTP server that they can put their spam in and send it. To get your mail, we have POP, Post Office Protocol, port 110, which was actually designed for dial-up, where you dial up, downloaded your email and read it. And IMAP, which uses port 143, or Secure IMAP uses port 993. It allows you to manage email on the server. This is the one that network administrators should be using, and not POP, because Post Office Protocol, you can download and delete it from the server, which would then prevent you from making the backup, and you may be required to make backups and maintain all emails in certain instances. For instance, if the company gets sued for anything, you've got to keep all of the emails from the time you're sued until the time that it's settled. Spam filters and mail gateways. Spam filters, I mean, on our private computers, we probably have a little spam filter. When it gets here, it goes into the junk email, and that's fine for us. But if you're on a large corporate network, if we accept all of that spam into your network, you've wasted bandwidth and processing power. So instead of filtering at the inbox level, we want to filter it before it gets to the mail server. So you have a spam filter out front that looks for or does filtering on, throws away mail. The problem with the spam filters, as you may have experienced, is that they sometimes filter legitimate mail. And generally, or what ours did was it said, we didn't send all of this stuff, this whole list of stuff, do you want any of it? And then you could put any of the addresses that had been filtered out onto your whitelist, and then you would get it. You may have a mail gateway or a mail relay. What generally is going to happen is we use those instead of going directly to the mail server. You have the relay in the DMZ. It processes the email, does the filtering and all that stuff, and then sends what it approves to the email server for delivery to the individuals. So it filters. What we want to do is filter it before it goes into our network, and that's a blacklist and whitelist. If it appears that you are a spammer, or if you are a spammer, those SMTP servers get put on a blacklist, and they then don't get their mail transferred from one server to the other. Another thing that may be used to verify that email is real is a reverse DNS lookup, to be sure that the domain that's listed in the email server is actually, or the email address is actually real. And tarp hitting is where you slow down the email, and so you slow down the spammer so that his software may actually give up on that. Recipient filtering, a friend of mine was doing that. He said that one of the first things he had to do with his filter was teach Linux to talk to Active Directory so that they could look to be sure that the email was actually to a real address. Because if it just goes to the domain, then it's going to be on the server. Again, more traffic and more processing wasted in the spam email. IDSs, intrusion detection systems, these are real-time analysis of either network traffic, or it could be real-time analysis of logs. What it basically is a sniffer with an analysis engine on it. We can have network IDSs and IPSs. The IDS is a detection, and it may or may not alert you in a timely manner. The IPS actually can stop the attack, the prevention system. So the IDS, the NIDS, the network is usually inside the firewall. It has to be inline. It has to be able to see what's going on. You can use a span port for this thing. It's passive detection. It watches the traffic and it compares it with its list of what problem what we are looking for in order to say, yes, this is an issue. It may have, and this says limited prevention, it may have limited prevention, that if it detects something, then it may be able to take some actions. The disadvantages of the IDS is a delayed response. You may not see what goes on, that there is a problem, until you look at the logs of these things. It can be overloaded. If you have a lot of traffic, can have high error rates. And this is another one that can't see encrypted traffic. None of these things can see encrypted traffic, so that's the way to get it through. The unified threat management It's an intrusion prevention system on IPS, a network IPS, and an IDP. Allows a combined firewall, IDS, malware scanner with active response. So it can actually respond to these things and prevent the attacks, or help to prevent the attacks. Take actions to modify what the network does. An inline device so that it sees everything coming into the network. It can do bandwidth throttling to prevent or slow down the distributed denial of service attacks. Can change or modify or apply firewall filters, quote, on the fly while using certain rules. It can do that. It can also do packet modification. So these are the unified threat management. Probably, if you can afford them, are the way to go with these things. We can have host-based intrusion detection, which is used on a single host, and this is a picture of the Symantec endpoint protection. It looks at different things and what's going on, same as the network one does. What's our traffic, and the traffic may be a big indicator how much network use you're using, how much network you're using, as to whether something odd's going on the network. So this can do basically the same thing that the network one does, except it does it on a host. The analysis engines are signature based. That means that they've got to be updated, just like signatures of antiviruses. And some of the attacks, many of the attacks don't conform to the specific signature, so they may or may not be detected, and that's what the error rate was on the previous slide. Behavior-based, uses statistical profile. You got to train the sensor to recognize the baseline or the normal behavior, and then it's going to then warn you about, after it learns heuristics, it learns, then it will warn you about the non-standard. We have a tuning period. They, again, high error rates in these things. Then the anomaly-based, anything that is non-compliant with the RFCs. Monitoring logs, what we're going to say here is we need to do that. Configure the operating system and the application log. You want to configure the system to log what you want to see. Some logs, very few really, but some logs in Windows are automatic, but you may have to go and set up the remaining logging. Here it says require authentication to provide an accurate audit trail, and then the types of logs. We have event logs, audit logs, security logs, access logs. Web browsers are typically going to log all connections, and this is where you may be able to look at that and say, hey, this is really odd. Why does this guy keep doing this? What's he trying to do? Is he trying to hack into my web page? And that may actually be the case. Logs can tell you a lot about what's going on the system, on the network. Baselines, thresholds, and log analysis. Baselines are the expected operation, what is normal. When we go through these things, how much traffic you got on the network is hopefully going to be a whole lot less at 2 or 3 o'clock in the morning than it is at 8 o'clock in the morning. The thresholds are the levels of either network traffic or maybe CPU or memory use or disk use that you're going to get a report generated. And the reports, alerts, and alarms, reporting alerts and alarms, what do you want to report on, what alarm on? Maybe the things that we just said. Disk space, memory use, processor use, what's going on. Let's talk about secure the logs against tampering. One of the ways to do that is to store them someplace else instead of on the machine where they are being logged. We want to keep the logs, keep them secure. Maintain the logs to prevent disk problems, because typically we're just going to keep adding to them. If you keep adding to them and don't do anything with them, you're going to one day go look and you're going to find yourself with a 2 gig log file. I have seen those, and they can't get that big, and these are text files, so you can get an awful lot of information in those. You need to do log analysis and reporting and look for trends when you do these things. And the security information and event management team can help you in establishing the way you want to do your log management. So we're close to the end, but we still got to do the questions. Know the types and features of the network, application firewalls, proxies, gateways, security appliances. Implement and configure the security appliances. The types and features of intrusion detection systems and the importance of logging and log configuration. Logging, again, is one of the things that we all hate to do, and log analysis is one of the things that we all hate to do, but it's one of the things you really need to do to find out, to see and monitor what's going on and anything strange going on your network.